regarding this lecture. So like I said, today we're going to begin talking about random variables. And like I said, probably we're not going to go through this in details. احنا دائما نحكي هيك بس we go in more details just تحسبا انه somebody has any questions. Just as a definition here, a random variable is a sample real function of the elements of a sample space. So it's real number, okay, real valued function, okay. So what we do here, we assign a number, okay, to the possible outcomes in the sample space S, or the universal set. So as it says here, given an experiment with the sample space S, okay, obviously the experiment will have some outcomes, okay. Each outcome we will assign a number to it, a real number, okay, based on specific rule, okay. And now we're going to take an example here to clarify what we just said. The random variable, it's always represented in capital letter, like X, like this one here, Y, and W. And the small ones, the particular values, or the outcomes, where the outcomes are represented in numbers, okay, they are small letters, X, Y, W, for example, okay. So let's say we have this example in front of you. Let's say if we have an example where we need to toss a coin 3 times. Now, tossing a coin 3 times, we will end up with 8 possible outcomes. Those outcomes in front of you, like either, you know, when you toss a coin, obviously, either you head or tail. You get head or tail. So if you toss them 3 times, each outcome, the first outcome will be, let's say, head, head, head. The other one is head, head, tail, and so on and so forth, until you will end up with tail, tail, tail. Okay. Now, if we say that we want to assign, okay, we want to assign a number, okay, for heads, when the outcome is a head. So, for example, the first outcome here, okay, has 3 heads. Then we will assign 3 to it. The second one has 2 heads, okay. So we'll assign 2. The other one is 2. This one is 2. This one is 1, 1, 1, and 0. Or maybe you want to say, no, I want to assign tails. So this 0, 1, 1, 1, 2, 2, 2, and 3. So the opposite, okay. So that's basically what the random variable is. We assign a real valued number to outcomes based on a specific rule. And our rule in this case, what? It's the outcome is a head or a tail. So if it's a head, then as you see in this table, it's x of small x is 3, 2, 2, 2, 1, 1, 1, 0. Then the random variable in this case has the values or the variables 0, 1, 2, 3, 4. Okay, that's basically what the random variable is all about. Okay, so you take a look at the outcomes. Okay, and of course the outcomes for the whole universal set or sample space, and you assign a number to each one of them based on a rule. You decide the rule. Maybe you want to see, let's say if we are tossing maybe dice or something like that. Maybe you want to see the outcomes when the combination is even or less than 5 or less than 4. So all these rules, you set them yourself depending on what you're looking for. So on page 1, basically, just clarifying what the random variable is all about. Now, page 25, we have 3 types of outcome, random variables. We have what we call discrete random variable, okay, which is a countable set. For example, like the example we just talked about last page, S is equal 1, 2, 3, 4, or X, for example. And the other one is a continuous random variable, okay, when we have the outcomes are uncountable. Okay. Example here, where S is larger than 0, okay, and less or equal to 12. So you have an infinite number or uncountable number of elements, okay? And then we have what we call a mixed random variable, where part of the random variable or part of the values are discrete and the other was continuous, okay? So begin to discrete and then it will continue something else. Obviously, this one is, we're not going to focus on it much. We're going to focus on 1 and 2, the discrete one, and then we'll talk about continuous. Okay. So the next thing we talk about probability mass function, PMF. Probability mass function will describe the discrete random variable. Will describe the discrete random variable. Okay, and it's written in as you see in equation 1 right here. Okay, and it will be in this form: the probability of x, you open parentheses, x of k, where k is 1, 2, 3 is depending on how many elements you have. Okay, so you'll find the probability of each one of them. Okay, so this is right here, p. P, capital P, the probability of the discrete random variable. It's written this way, and it's called PMF of x. So as an example right here, so if we are flipping a coin once, the outcomes will be either H, head, or tail. So if we assign 0 to a head and 1 to a tail, so it means the random variable in this case has 2 elements, 0 and 1. So the PMF for the 0, in this case, or you can write it x is equal 0, either way you want, is equal half. And the other one, the PMF for 1 is equal half. Okay. A couple of things we need to know, and we already know actually. The following must hold for discrete random variable. Of course, equation number 5 says the PMF will have to be between 0 and 1. Of course, it's a probability, and we did establish that the probability it's between 0 and 1. Cannot be less than 0, and cannot be more than 1. Okay. And also, the total probability, the total PMF for each sample will add up to 1. So, for example, if you go here to equation 4, if you add up PMF for 0 and 1, it would have to be equal to 1. Now, if you go back to the first example here, we have 0, 1, 2, 3, and we have a PMF for each one of them. So you add them all together, and they would have to be equal to 1. Otherwise, it's not valid. Okay. Next, we're going to talk about some types of or some examples of discrete random variables. Okay, on equation 26. Now, the first one, it's called Bernoulli random variable. And this is very simple, the simplest possible random variable. And it represents, as I'm showing here, it represents 2 possible outcomes, okay? And most of the time is 0 and 1, which is basically like flipping the coin. Flipping the coin will give you either 0 or 1, or head or tail, okay? So flipping a coin is a Bernoulli trial, okay? So every time this experiment, flipping a coin, is a Bernoulli trial, okay? And obviously each experiment, the experiments themselves, they are Bernoulli trials, okay? And the results are random variable. They are Bernoulli random variables. So in our case here, when you flip the coin, you will get head and tail. And if you say head is 0 and tail is 1, or vice versa, so your random variable here, the Bernoulli random variable, is 0 and 1 as shown here. Now the PMF for the Bernoulli random variable with the parameter p, small p that is, it's not capital P. Capital P is for probability. Okay, it's given in this equation. So if we end up with 0, okay, whether it's head or tail, you decide that. Okay, let's say x is equal 0, then it's 1 minus p, and if we have x is equal 1, then the PMF is p, and otherwise will be 0, where p in this case is half, right? Because either head or tail. Now head is 1/2 the PMF for it, and the other one is half as well. So when p is half, small p is small p, small letter p is half, will be 1 minus p, will be half. Okay, so that's the first one, Bernoulli. Now let's take a look at binomial random variable. Binomial random variable, it's like Bernoulli random variable, except we do the experiment, the trial n times. So if we are flipping the coin once, so that will give us either 0 or 1. Where if you flip it maybe 10 times, it will give us, of course, each outcome will be 0 and 1. 0, either 0, 0, 0, for example, and the rest of them are 1s. Okay, so basically the binomial random variable is repeating Bernoulli trial n times. Okay, and it's given in this equation right here. And sometimes we refer to it as a Cartesian space. So as an example here, if we are flipping the coin n times, so the outcome of k, the outcome will be 1, 1, 1, 1 k times, okay? And zeros will be n minus k, because the total will have to be n. So we flipped it n times. So the first one will be 1, the second one will be 0, the third one will be 1, and so on and so forth. So when you add up, the ones will be k, and the zeros will be n minus k, where the total will be n total trials. Now, we did say that each outcome is independent of all other. So they are independent of each other, okay? Accordingly, the probability of these outcomes, okay, we can find them by finding the probability of each one of them, each outcome 1, 1, 1, 1, 0, 0, 0, and multiplying by each other, as shown in equation 10, because they are independent of each other. Okay, now equation 10 can be rewritten as an equation 11. Okay, as you can see here, the probability of k is equal to the probability of 1 to the power k, and the probability of 0 to the power n minus k. And we can replace this one, the probability of 1, from Bernoulli by p, small p that is. Okay, it's not capital P, small p. Okay, so to the power k, and the other one 1 minus p, n minus k. Okay. Now, if we go to equation 27, we're going, without going through a lot of details, we need to find the random variables. Okay, we need to find the PMF of the binomial random variable. Okay, let's assume that this example was done already. Okay, and the way you find the PMF of binomial random variable x is taking the number of outcomes in AK times the probability of each outcome in AK. Okay, and of course we have a lot of details in the book. The only thing we're interested in equation 13, where equation 13, this one here, the first one, the open parentheses NK, this, it's called the binomial coefficient, and it's represented in equation 14. The binomial coefficient is n factorial divided by k factorial times the n minus k factorial. Okay, and this is a well-known coefficient. Okay, so all we did, we just, if you go back to the previous page, we took equation 11. Okay, and we multiply the outcome of equation 11 by the binomial coefficient, which is right here. Okay, and that's basically it's a well-known binomial, the PMF for binomial random variables. Okay. Okay. Now, if we need to verify that this is valid, this is a valid PMF. The total PMF for each outcome will have to be equal to 1. Will have to be equal to 1. So we'll begin. So right here, we can use equation 15, as you can see here. So we take this one here. And as we said, we have n trial, okay? So we start from k is equals 0 to n. And obviously, we use this mathematical expansion. طبعا احنا we didn't expect to memorize all of this right here. This is just to show you this is a valid one. This is from the math book, okay? So if you take this one and plug it back into this equation right here, you will end up with p plus 1 minus p is equal to 1, which means this one is valid. Okay, that's all we need to know. We didn't need to know. We didn't need to remember all this because this is يعني موجود already in the math books. ما في داعي نحفظها. But we know it's called binomial expansion. Okay, so we know the binomial expansion. يعني أنت as long as you remember how to find them. وإحنا مش راح نركز إنه يعني إحنا هلا يعني the only thing we are looking for is to understand the examples we are talking about. Okay, الماث هسه مش يعني مش مهم كثير بالنسبة للمواد النقطة هاي. Okay. Page 28 is talking about Poisson random variable. Okay. Now again, if we talked about so far about 2, we talked about how many? We talked about the Bernoulli random variable, and then we talked about binomial, and we said binomial, it's multiple trials of Bernoulli, and then Poisson random variable, it's related to Bernoulli by saying if n trial in binomial random variable, okay, now this one is depending on binomial, where binomial is depending on Bernoulli. So كلهم يعني بيعتمدوا على بعض. Okay, هلا if n trial in binomial random variable is very large, so let's say if we decided to do the trials 1,000 or 10,000 times, okay, but the success of each individual trial p is small, so we are looking for a specific outcome p. بالحالة هاي is small. In this case, we can approximate it by using the Poisson random variable, okay, which is given in equation 17, okay, where the PMF of Poisson random variable is given in this equation, which is alpha to the power k. Of course, k is the number of trials or the number of occurrence, and alpha is the average number of events occurrence in specific time intervals. By the way, Poisson, it's really used, I have a few examples here. It's really used in stats, like, for example, obviously it's used in communication a lot. It's used, for example, in traffic engineering. So if you wanna plan something, when we say traffic engineering, sometimes we refer to communication, like phone calls, traffic engineering, or car traffic engineering. I mean, they use the same theories, okay, almost. So, for example, if you take a look at خلينا نقول شارع البتراء, and you want to see how many cars is passing by during specific time, okay, in an hour or in a minute, or maybe in the afternoon or something like that. So they use, in this case, the Poisson random variable. And also, for example, يعني مثلا they use it like as an example here, the number of data packets arriving at a given node per minute. Okay, we use the queuing theory. طبعا مثلا شركات الطيران بيستعملوا queuing theory. ليش؟ لأنه they want to see the callers, how many calls are using the coming per minute. Okay. So they can decide how many stations they need to build or things like that. So it has so many applications, okay? And also we can verify it's properly normalized, as you can see here, okay? As in equation 18 is equal to 1. We all know how to do that. That's nothing new. And finally, it's about the geometric random variable. Okay. The geometric random variable, again, it's the PMF for this one. As you can see here, we are focusing on the PMF of each random variable, of each discrete random variable, okay? Because this is the most important thing, is the PMF, the probability mass function, okay? So the PMF is derived for geometric random variable, is derived from the Bernoulli random variables, okay? Which basically what we're doing here, it's repeating something, let's say Bernoulli several times until we get a specific outcome we are looking for. For example, if we are looking to get, let's say if we are flipping a coin, and we are interested in getting a tail, okay, or 0. Okay, let's assume the tail is 0. Okay, let's assume the outcome tail is assigned number 0 to it, and head is 1. Okay, so you keep flipping the coin until you get 0. So the number of trials you flip, the number of tries you do it until you get the specific outcome you are interested in. Okay, this is the number of measurements we are looking for. That would be X. For example, you flip in the coins 4 times, okay, and each time you get 1, 1, 1, 1, okay, and the 5th time you will get 0. So X will be equal to 5, 1, 1, 1, 1, 0. So then you will use this equation right here, okay, to calculate the PMF for the geometric random variable, okay. And obviously we have some more, maybe in the book, I don't know, more generalized ones, but we're not going to go through this. The only thing we're interested in, that geometric random variable is working on, you're doing something until you find the specific outcome you're looking for. Maybe you flip it once and that's it, will be 0. So the try will be 1, right? In this case, will be 1 minus k, 1 minus p will be half, okay? Or flip it 20 times, okay? And you always get in 1, 1, 1, 1, and the 21st time, it will be 0. Then k will be 1 through 21, 1 through 21, and that's basically what the geometric random is all about, okay? So I'm not going to go through more details about it, because the only thing we're interested in is equation 19 at this point, okay? Okay, any questions بالنسبة للنوتس هون بالنسبة للمادة هاي so far؟ كل شيء تمام؟
تمام دكتور.
Okay. All right then, let me see. If you didn't have any questions, let's see how many we have here. We have if you didn't have any, does anybody have any questions and general questions? Everything is okay?
بس أنا في عندي سؤال. هسه المحاضرة حكيت لنا إنه احتمال في كويز الأسبوع الجاي، فما بعرف إذا في أو لا.
الكويز يعني احتمال، احنا قلنا يعني possibly the 4th week, which is الأسبوع الجاي will be the 4th week ولا لا؟
تمام بالضبط.
اوكي. هلا the 4th week احتمال. طبعا اليوم احنا شو اليوم الثلاثاء، مش رايحين نعمله يوم الأحد. لو بدي أعمل يوم الأحد كان حكينا لكم، احتمال نعمله الأحد اللي بعده بكون خلينا نقول ايش، the 8th كأنه the 8th of November.
8/11 بيكون تقريبا.
بيكون 8/11 يعني مش الأحد الجاي، الأحد اللي بعده. واحتمال أعمله الساعة 3. أنا بودي إيميل للجميع إن شاء الله، ممكن لما أكد 100% نهاية الأسبوع هذا أو على الأقل بداية الأسبوع الجاي. والمادة بعتمد يعني قديش إحنا بدنا نغطي this week and next week. ممكن نغطي chapter 2 كله، ويكون شابتر 1 وشابتر 2 داخلين بالكويز. الكويز طبعا عليه 10 علامات يعني مش كثير، بس برضه اتس كويز. اوكي. والمد ما بعرف ما حددوش، بس بتوقع المد راح يكون most likely the 7th or 8th week or 9th week، ما بعرف. بتوقع راح ينزلوا الجدول عشان المد. اوكي. بس احنا هلا الكويز مثل ما حكينا مش راح يكون بداية الأسبوع الجاي، يعني أنا حاط ببالي حتى بداية الأسبوع اللي بعده، يعني بداية الأسبوع الخامس بنكون مخلصين 4 weeks، فالكويز بكون بداية الأسبوع الخامس اللي هو يوم الأحد إن شاء الله. أوكي.
دكتور يعطيك العافية.
أهلا الله فيك.
بس يا ريت يكون مش على الساعة 3 لأنه عندي محاضرة بكون.
طيب أي ساعة بكون؟ شو محاضرة
يعني
الساعة 3 بتكون عندك؟ الساعة 3
عندي محاضرة نيوميريكال من 2:30 ل4 دكتور.
ليش مأخذينهم؟ مع مين مأخذينهم؟ مع انت اي تي عفوا. انت اي تي عفوا، انت مش
لا انا كهرباء.
ليش مأخذينها هيك مثلا؟ هي 2:30 ل4 دائما؟
والله ما بعرف دكتور بالضبط، يعني مش متذكر، بس هيك زبطت معي.
مش زبطت معك
دكتور ما في غير
هيك مكتوب. انا بعرف كل
دكتور ما في غير شعبة.